In this short tutorial, I'll show you how to find the binomial coefficient. The formula for the binomial coefficient is shown on your screen right here, and this part is read n above r. The question reads, evaluate each of the following binomial coefficients. In the first one, we have 6 above 3. So let's go ahead and substitute 6 where we have n in our formula and 3 where we have r. We have 6, and this exclamation mark is factorial. I'll explain what that is in a moment. Over 3 factorial, bracket, 6 minus 3 factorial. I'll simplify this expression. 6 minus 3 is 3, so I'll replace this with 3. And now we have to determine what this factorial means. What this means is 6 times 5 times 4 times 3 times 2 times 1. So if we have this expression at the top and 3 factorial at the bottom, which is 3 times 2 times 1, these factors will cancel out, leaving us with, at the top, 6 times 5 times 4, and at the bottom, 3 factorial only, this part, 3 times 2 times 1. And if you put this into your calculator, you should end up with 20. Let's do the next one. This time we have 6 above 0. So we'll write down 6 factorial over 0 factorial, which is equal to 1, bracket 6 minus 0 factorial. I just mentioned that this becomes a 1. We have 6 factorial at the top and 6 minus 0 factorial at the bottom. Therefore, our answer is 1, because we have the same factor at the top than we do in the denominator. 8 above 2. Let's go ahead and do our work over here. 8 factorial over 2 factorial. 8 minus 2 is 6 factorial. Let's go ahead and expand the numerator. We end up with 8 times 7 times 6, and I'll stop there and write down 6 factorial. And at the bottom, this 6 factorial and this will cancel out. So this cancels out with this. We have 8 times 7, which is 56, divided by 2 factorial, that's 2. Our answer is 28. Lastly, 3 above 3. We'll work over here since we're running out of room. 3 factorial over 3 factorial. 3 minus 3 is 0 factorial, that's 1. We have 3 factorial and 3 factorial at the bottom. Those cancel out, leaving us with 1. Now you're probably wondering, why are we even doing this? What's the point of finding the binomial coefficient? Well, if you recall, we have looked at the binomial theorem in the past. And the binomial theorem gives us a way to expand binomials of nth exponent. So if we had a binomial, let's say a plus b to the power of 100, we can use the binomial theorem to help us expand it without having to do it manually. And what we were finding in question 1 were these things, what's highlighted. So let's go ahead and set up and expand using the binomial theorem here, using the knowledge we just acquired in the first question. Here we have an a value of x and a b value of negative 2y. Our n, which is the exponent, is 5. So all we have to do is set up and expand. So the first one will be 5 above 0. And we discovered that when it's a number above 0, the answer is 1. So the first term will have a coefficient of 1 always. Hence, we have a to the power of n. Our a is x. X to the power of n is for the first one. And of course, don't forget to substitute the n with a 5. Then we have 5 above 1. And 5 above 1 is the exact same thing as simply n, as highlighted in blue here. So we have x to the power of n plus our second term is 5. A is x raised to the power of n minus 1, which is 4, times b, negative 2y. We'll do one more term and then I'll show you the final expression. Next we have 5 above 2. And that is the same thing as saying n bracket n minus 1 over 2 factorial. So we have 5 bracket 5 minus 1. That's like saying 5 times 4, 20. 20 divided by 2 factorial is 10. So I'll write down plus 10 x to the power of 5 minus 2, that's 3, and b raised to the power of 2 gives us 4y squared. Now, of course, you would multiply 5 and negative 2 in this term and 10 and 4 in this term, and you would find out the simplified version. The rest of the terms should look like this. What you see on your screen is the simplified expression of this binomial being set up and expanded. And there you have it. That is how to find the binomial coefficient.